Okay, today we are going to talk about what is called the discriminant. Okay, let's look at the quadratic formula. All right, so here's a typical quadratic equation in the standard form, ax squared plus bx plus c. Let's say this is equal to 0 and you want to find your roots, right? You have to find the roots, okay? You want to find solutions, right? Solution roots, zeros, right? Zeros and what's that? There was zeros and say the x-intercepts. All these mean the same, okay? Because when you're solving for quadratic equation, what you're solving for is the x-intercept of the equation, the same as the roots, solution. Okay, so here's the quadratic formula, okay? And you should know this formula here is x, okay? X, those are, you're going to get x1, x2. This is how you find it. It's equal to minus b, that means b is what? The number multiplying your x, plus or minus square root of b squared minus 4 times a times c, everything divided by 2 times a. That is a quadratic formula, okay? We all know that. Okay, now look at the part here under the radical sign. The b squared minus 4ac. The b squared minus 4. This is called the discriminant. What word comes to mind when you hear discriminant? Okay, it discriminates, right? Okay, discrimination. All right, so the b squared minus 4ac, just that one is not the square root of b squared minus 4ac. It's just the b squared minus 4ac is the discriminant. Okay, what does that tell us? What does that tell us? Okay, so when you solve for quadratic equation, for example, if you're given x squared plus 10x plus 21 equals 0, and you are asked to find the values of x, right? Factors of 21 that add up to 10, that's 3 and 7. Okay, so we factor it x plus, and then we solve, and then we get x equals negative 3 and x equals negative 7. So negative 7, okay, those are the points. Those are the x-intercepts, okay? That's where the curve crosses the x-axis. All right, that is your typical, okay? That's the typical quadratic equation, okay? So the ones that you have the curve crossing the x-axis, what happens, okay? How do we know from the discriminant? If we evaluate the discriminant and we get a number that's greater than 0, we know it's got two distinct solutions, negative 3, negative 7 as example. Okay, so b squared minus 4ac, let's see, let's compare the ax squared plus bx plus c. Okay, using this, our a equals 1, b equals 10, and c equals 21, right? So we find b squared minus 4ac, b squared minus 4ac. This is the discriminant. B squared, which is 10 squared, which is 100, minus 4 times a, 4 times 1, right, times 21 minus 84. What is that? 16. See that? And 16 is greater than 0. So if we do the discriminant and we get number greater than 0, then we know we are going to have two distinct roots. So we can use the discriminant to tell us what kind of solutions we have. Okay, we can also have a situation where the discriminant is equal to 0. Equal to 0. What happens? Okay, so pay attention to the graphs, what it looks like when the discriminant is greater than 0. What if it's equal to 0? Okay, what's the nature of the graph? Okay, when it's equal to 0, you're going to have one solution only. Okay, the graph is just going to touch the x-axis. Example, if we have x minus 2 all squared equals 0, Okay, if you break it down, you see x minus 2 all squared. If you can take square root for both sides, and you get x minus 2 equals 0. And that means x equals 2. Okay, only one solution, one solution only, and it looks like this. So we have greater than 0, the discriminant. We get two distinct solutions equal to 0. Okay, it's called also repeated roots. Okay, because why do we call repeated roots? It's because x minus 2 here, this one here, if we write x minus 2 all squared as x minus 2 times x minus 2, and then we solve each, you will get x equals 2 and x equals 2. It's the same thing. X equals 2 twice. It's repeated roots. The same thing. All right. So we know two conditions. Let's go to the third one. The third one is the discriminant is less than 0. It's less than 0. Right? If it's less than 0, we are not going to get real solutions. Okay, we have solution, but it's non-real. It's going to be imaginary. All right, and it's going to look like this. And that means it's not going to touch the x-axis. It looks like this. Okay, for instance, if I have x squared plus x plus 5 equals 0, you try solving this, right? You see, you cannot factor it. And if you use the quadratic formula, you see the b squared minus 4ac is negative 19, which is less than 0. That means you're going to have square root of a negative number, and you know it's not a real number. Okay, so you got the three scenarios, right? Let's summarize. The discriminant, and the discriminant is just the b squared minus 4ac. Okay, it's not the square root of that. It's the b squared. If it's less than 0, we have non-real solutions or imaginary solutions. Okay, we have no real solutions. Okay, if it's equal to 0, we have repeated roots, and it touches it. And we have greater than 0, that's your typical quadratic solutions. Then you got two distinct solutions. Okay, so let's try and do one question here, how we can apply the discriminant. It says determine the value or values for k such that kx squared minus 6x plus 3 equals 0. We have two non-real solutions. How are we going to do this? So you look at it. Okay, I said, all right, use Uncle Solo's problem-solving guide. All right, we're going to make the question familiar. Okay, let's identify some keywords, phrases, expressions. Okay, so we look at it. We have a quadratic expression. Okay, so we start thinking this is about quadratic equations. All right, we also have what you call what? Non-real solutions. Okay, that's a hint. That's a hint. And then you start thinking the discriminant. All right, what is a discriminant? B squared minus 4ac. Okay, when it's going to be non-real, what happened? What's the condition for non-real? Is that the discriminant is less than 0. So we write kx squared minus 6x plus 3. We compare it to ax squared plus bx plus c, the standard quadratic equation. And then we say a equals k, b is 6, c is 3. And then we come and plug that in. We kind of plug that in the discriminant. All right. So b squared, b is negative 6. Negative 6 squared, all right? Negative 6 squared minus 4a. Okay, a is k, c is 3. We plug it in. So 36 minus 12k should be less than 0. And then we solve this, right? We solve this. So we say 36 will be less than 12k. And then we solve for k, we say divide both sides by 12. And then we get k greater than 3. All right? K greater than 3. So the answer to the question is, what values of k? All values greater than 3 will make this non-real. See that? All right? Realize it's a quadratic expression. Okay? Another keyword or phrase, non-real solutions. We thought about the discriminant. What is the condition for non-real? The discriminant should be less than 0. We went and plug it in. We solve the inequality. So when k is greater than 3, this will have non-real. Go and practice more here. Send me any questions you have. All right, keep on practicing. As I tell you, all things being equal, you shall what? You shall bloom. Welcome to Perfect Review, SAT Math by Bloom Leadership Academy. Have a good day.